blocks is well known as the NP-complete for general instance. Our first contribution consists to show that Cbm is NP-complete even when the binary matrix has only two ones in row. By polynomial transformation, the problem of the maximum weight of Hamiltonian path to Cbm restricted to this instance in question. Second contribution is to solve this question: is Cbm approximate with guarantee? First, the new negative result. Cbm is NP-complete even when the binary matrix has only two ones in row. Our goal is to prove that Cbm is NP-complete even on special instances that are binary matrix having only two ones in row. We consider the problem of the maximum weight of Hamiltonian path, but restricted to instances with a weight equal to 1 or 2. We propose a polynomial transformation that reduces any instance of the second problem to an instance of the first. The formulation is presented below. The 2 Cbm problem. Consider the restriction of the Cbm problem called 2 Cbm. The matrix having two ones in row. Consider also the restriction of the maximum weight of Hamiltonian path problem called 2MWH, where the weight of the edges have a weight equal to 1 or 2. The 2 maximum weight Hamiltonian problem is an NP difficult as long as the Hamiltonian path problem can be directly polynomially reducible to 2MWH problem. The instance is a graph G, and the question is there a path that goes through all the vertices exactly once? Here we are looking for a path through all the vertices and whose weight is maximum. The transition from the 2 maximum weight Hamiltonian problem to Cbm. This form is to make a restriction in the original problem by formalizing the problems based on the weight restriction of the edges that are degrees 1 or 2. We will actually study the version of the problem where the weights on the edges connecting the cities obey to the triangle inequality of Christoffel. Without this restriction, the problem cannot be approached. It is known also for graphs obeying to triangle inequality. The Traveling-Salesman problem is 1.5 approximation, which means there is an algorithm capable to give a solution less than 1.5 times the optimal solution. The polynomial transformation. Here we show that the 2MHW problem could be reduced polynomially to the 2 Cbm problem. For this, we must present a transformation that shows that each instance of the 2 maximum weight Hamiltonian problem is an instance of the Cbm problem. Demonstrate that is polynomial. Prove that the Hamiltonian path P has a maximum weight if and only if it induces an order P of columns which minimize the number NAP. The transformation procedure could be presented as algorithm below. By this construction, A is binary and contains 2 non-zero elements in row. The complexity of this transformation is like this. For this, we mention 2 propositions and proof below. We clearly shows by proposition 2 that the columns order P of the matrix A minimize the number NAP if and only if P is the maximum weight of Hamiltonian path. As a conclusion, an immediate consequence of polynomial reduction is that the 2 Cbm is as difficult as the 2 maximum weight Hamiltonian problem. The second part of our paper concerns the new positive result. Minimizing the number of consecutive blocks is approximate. Here we will recall the formal definition of the following 3 combinatorial optimization problem. The first is the minimization of the number of CB1s. Instance is a matrix with integers, and the question is there permutation P such that the number of entries checking some condition equal to K? Second, the minimization of the number of circular block consecutive ones. The instance is a matrix with integers, and the question is there a permutation P so that the number of entries checking some condition is equal to K? The third one, the symmetric traveling salesman, the instance with positive integers, and symmetrical distance matrix D. The question is there a tour P between cities such that sum is equal to L? The purpose of the Cbm optimization problem is to look for permutation of the column of A, which gives a minimum number of coefficients seated in the definition of Cbm. The question is, can we approach the Cbm problem with a proof of performance? Let A a Cbm instance and optimal A the minimum number of the desired entries of A. Is there a polynomial time heuristic H and alpha such that all instance HI less or equal alpha optimal points optimal A? The procedure is below. First, we will polynomially transform Cbm problem into a SIR problem. Then a second transformation of the SIR problem into the organic salesman problem, which obey to triangular inequality. As those two transformations are approximately preserved, and as we know that the heuristic of Christoff's minimum spanning tree is approximate for the traveling salesman problem, so this is a heuristic for the Cbm optimization problem. The approximation of the Cbm optimization problem. A block of consecutive one in row E is a sequence of ones occurring consecutively and satisfying the following condition. Clearly, there is one-to-one correspondence between the coefficient mentioned in the definition of Cbm problem. Similarly, the circular block in row E is either a consecutive block or a concatenation of two consecutive blocks. There is also a one-to-one correspondence between the coefficient mentioned in the definition of the SIR problem. So the question of the SIR problem becomes, is there a permutation P such that the number of circular blocks in AP is K? As follow, we propose to make the three propositions below. Approaching Cbm to SIR by this procedure, approaching SIR to the traveling salesman problem by this procedure, here where the matrix D is an instance of traveling salesman problem represented by the n plus 1 cities distance matrix. And we note that the permutation P of the n plus 1 columns of B have a circular block if the tour length L equal to K. Suppose also that C equal BP, having K circular blocks, and we want to know if L equal to K. From the definition of the SIR problem, the value L is exactly twice the number of circular blocks in C. The procedure is presented below for identifying the circular block in row E. The proposition 3 shows that the traveling salesman problem with the distance matrix T obey the triangle inequality. Given the binary matrix A, and let's consider the following heuristic for the Cbm optimization problem. We apply the transformation to obtain matrix P, obtain an instance D from TS, finally apply a heuristic of Christoffel with distance T. Clearly, This heuristic for Cbm optimization problem is polynomial times such that the solution generated does not differ from optimal by more 15%. The conclusion, we have presented two important results on which we established the polynomial time heuristic to solve the Cbm problem. We have shown that it is hard. Recall that the symmetric matrix T instance of traveling salesman problem is not ordinary. It obeys a law of triangle inequality with a new property. Each coefficient of the matrix D shall not exceed the number n of the rows of the matrix A, and each cycle has an even length. The question that remains is, do those two properties allow us to do better? Many applications can be found into this problem in biology science, physical mapping, DNA sequencing, and radiation therapy session, planning, scheduling, and memory management. Thank you for listening.
Thank you very much. Hello.
Yes, Dr. Qasim.
Thank you very much, Dr. Zubair. And now we go to the second presentation.
The next paper, Code 162, multi-level classification of Pakistani.
Yeah, I can hear you. Dr. Qasim here.
Yes.
Yes, I'm hearing you. I didn't see.
So,
Okay.
Dr. Mahmoud, who is speaking?
Yes, Dr. Qasim.
Yeah,
yeah, I can
yes,
hear you.
I'm hearing you. You can.
Okay, we
Can
can
I
continue.
start?
We will start from our computer. We have video.
Okay.
Okay. Can you see the presentation now?
Yes, now
Okay, let's start.
I see.
This is Suraya Obed. I'm here to present our research titled as Multi-Level Classification of Pakistani News Headlines using Machine Learning. Dr. Numi, Rukaiya Bahani, and Anam Ilyas have co-authored this paper with me. Here is the presentation outline. I will be discussing all of these in the next few minutes. Background of this study, research objectives, methodology we have used within this experiment, results obtained, and their future direction. Data is being generated on a daily basis regarding news and events happening all around the world. And this news is being produced at almost every single second. This data can be beneficial only if it is processed effectively. This means it has to be classified in a meaningful way. If this classification is done manually by human resources, then it can be tedious as well as time-taking. So what is solution? Text classification is very popular application of machine learning that is basically done on principles of natural language processing. It's a simple mechanism. It actually extracts keywords from the text to be classified and discards all unnecessary components of text. On the basis of extracted keywords, classification is done. Text classification is beneficial in several scenarios such as sentiment analysis over user feedback or opinions, content and product or content or product tagging, etc. Now here are objectives of our research that include classification of news headlines, categorization in predefined classes, are objectives of our research that include classification of news headlines, categorization in predefined classes, and extending this classification to multi-level classification. Methodology we have used here in this experiment is pretty straightforward. Data collection, preparatory steps that are commonly used for natural language processing, then training of data set using machine learning algorithms, and then performance evaluation. So this one is first step of this experiment, that is data collection and partitioning. We have used dataset of Pakistani news headlines. It is basically a subset of dataset obtained from Open Data Pakistan. This one had more than 27,000 instances, but for this experiment, we have used around 2,000 instances. Dataset was manually classified for second level by 2 indicators. First level categories are Pakistan, finance, and sports. By second level categories were 11 in total. We have divided by 80-20 ratio for screening and testing. In the second step, data preprocessing was done. A number of preprocessing techniques were applied that are commonly used for natural language processing with the help of Python library. These techniques include tokenization, stopwords removal, and stemming. Feature selection was done using a technique called TF-IDF, which is abbreviation for term frequency inverse document frequency. TF-IDF is calculated as occurrence of a token W in a sentence summed across all of its occurrence in a particular class. Next step was algorithm training. Four algorithms are used in the experiment, including Bayes, logistic regression, SVM, and random forest. Here are the results that we got at the end of experiment. In total, 4 algorithms were used, and out of those, Bayes gave best results for first level classification with accuracy score of 97.89. While for logistic regression, the accuracy score was 96.18, which is comparatively lowest among all. So discussion so far was about single level classification that was done using 4 machine learning algorithms. We actually furthered our experiment by applying multi-level classification on same data set. Another level of categories was introduced, having 11 subcategories. And for this particular part of experiment, we have used logistic regression. Logistic regression is known for giving more precise results and accurate results, especially when it is compared with Bayes, which gave best accuracy score for single level classification. So these are the results that we got after applying logistic regression for multi-level classification. Accuracy score for the first level was 96.8, while for second level, accuracy score was 83. Here are future directions we plan to explore. We look forward to add more category levels and instances in future to get more precise and better results of classification.
Done.
Thank you very much. Thank you very much.
Let's go to the next.
The third present here.
164 Scientific Data Generation for Machine Learning. Muhammad Abu Fada and Khalid Mansour, Zarqa University, Jordan. Any person from this paper join us now, attend, because we didn't have video, we didn't receive the video.
Yes, doctor, there is a video.
Okay, so you will do the presentation or the video, you have video? Abu Maher?
Doctor,
Yes.
join as a panelist.
Yes, I give you the permission. So just accept and go to the panelists. Yes. Abu Maher, leave. Okay. Now, Abu Maher, you can unmute the mic. All right.
Do video.
Yes, just a minute.
Okay. So now you have permission to share your screen and play the video.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته.
Still not
My name is Muhammad Abu Fada and I am studying a master's degree in computer science at Zalka. Can you
Abu Maher, we cannot see, but just hear.
see the video, doctor?
We didn't
No,
see the video.
no.
Just hear the sound.
You hear your son.
Share screen and again start. All right, now it's okay.
Yes, now
Okay. بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. My name is Muhammad Abu Fada and I am studying a master's degree in computer science at Zalka University. I will present to you a presentation related to the research paper entitled A Survey of Synthetic Data Generation for Machine Learning. And to begin with, we will talk about introduction. If machine learning algorithms can be described as a combustion engines, then data can be described as its fuel, even though data are currently generated in a huge amount than before. In many cases, data shortages hinders our ability to benefit from using machine learning algorithms in predicting future events and classifying objects. Issues such as privacy or national security may limit the amount of available data, and using the machine learning algorithms becomes a challenge. As a result, for the foregoing, the field of synthetic data arose, and the demand for it grew along with the development of machine learning and the new applications based on it, which contribute to the development of methods and techniques for creating synthetic data, as well as the evaluation of these methods and techniques in order to assess the quality of simulation of real data on the one hand, and improving training machine learning models on the other hand, so as to find out the best ways to get an alternative to the original data. There are challenges for data sets, like obtaining data that is large enough for machine learning algorithms, confidentiality and privacy of data for patients in healthcare system as an example, requesting data from official authorities and taking approvals. It may take a long time that can reach from 1 to 2 years. And there are international laws and regulations that protect this data and prevent easy access, like a General Directive on Data Protection, GDPR, in the European Union, and Health Insurance Portability and Accountability Act, Privacy, HIPAA, in the USA. So the main idea of this research, we conducted a survey of the most recent studies dealing with the field of creating synthetic data, and we clarified the methods they used in their experiments and studies, as well as summarizing their findings. We focused our research on the healthcare systems, and we included previous studies that use synthetic data in other fields like finance to make our research more comprehensive. Now we will talk about some of the synthetic data for healthcare systems of related works.
أبو ماهر أنت الزمن
and their methods and results.
ما حيكفيك.
In a brief, like this article talked about synthetic PPG generation from hemodynamic model with pair reflex autoregulation. They used digital twin platform as a method. Results there were synthetic data obtained better accuracy in machine learning models. Here we talk, for example, general synthetic medical images by using GAN to improve CNN performance in a skin cancer classification. This is their method was generative adversarial networks, GAN. The results were CNN trained on synthetic data was better than that a database trained on raw data. Another article, they used recurrent neural network RNN. The results were better quality in generating synthetic signals. Data generated are very similar to the original data. Here, for example, medical image translation using GANs. They used a developed method of GAN called MedGAN, medicine GAN, MedGAN, and the results was the model exceeded other frameworks quantity in generating medical images. Here in this article, GAN-based synthetic brain PET image generation. Their method was deep synthetic convolutional adversarial networks. Their results were identical results between synthetic images generated and real images. For example, this article talked about COVID GAN data augmentation using auxiliary classifier GAN for improved COVID-19 detection. Their method was COVID GAN, and it's also developed a method of GAN. The results was increasing accuracy for the CNN from 85 to 95%. In this article, for example, effectiveness of synthetic data generation and the capsule endoscopy images. They used the 3D and real-time addition to machine learning agent and SOFA and into SFM learner. Their results will improve the performance of neural networks. Here in this article, synthetic data generation for optical flow evaluation in the neurosurgical domain. They used a blender synthetic data for Fernback and PWC nets. They result better information for WCNet algorithm compared with the Fernback. For this article, for example, synthetic data generation system for AI-based diabetic food diagnosis. They used the neural profit prediction model. Their results were strength for system. High accuracy improves the diagnosis of diabetes diabetes patients. And the rest of these related works were about healthcare systems and their method, like GAN, histoGAN, data synthesizer, synthetic data vault, parameter centerbook. And now we will talk about synthetic data for non-healthcare systems. And like this article, synthetic data generation for end-to-end thermal infrared trafficking. They use cycle GAN. The result was feature trained with synthetic data outperformed other real data. Combination of synthetic original data greatly improves results and performance. This was about generating synthetic data in finance, opportunity challenges and pitfalls. They used XML-based synthetic, Gibbs sampling-based method, agent-based modeling, APM, and quant GAN. The results were improved accuracy of synthetic data. Like example, for example, synthetic, this article, synthetic data generation for steel defect and classified learning. They use a 3D application called Blender as a method. Their results were serious results in classifying defect for hard steel plates. And the last, the conclusion talked about this paper reviews the recent work in synthetic data and focuses on the methods used to generate new data sets for healthcare system, as well as the methodology of producing these data sets. We discussed the findings of these studies as well as the utility of these strategies. This study presents a few studies that tackle the problem for generating new data in fields such as financial and industrial sectors. As future work, we aim to investigate the utility and efficiency of different synthetic data generation methods empirically and come up with generalized results that help the research community in selecting the most appropriate methods for different scenarios. And thank you all for listening.
Thank you. Thank you very much.
Thank you very much. Now we will move to the next authors.
I am online. If you want, I can present my presentation in live mode.
Thank you very much. But now we are ready to do the presentation. Just let's go.
No problem. No problem.
With the video, and at the end, inshallah, we'll see. Thank you very much. Okay. Now we have 168 paper code and efficient system to predict customers' satisfaction on heuristic services using ML and DL approaches. Saeed Qadiri أو قادري, Sarah Wald, Mehdin, and Herizi, Safi, and Shapira. University Mohammed
Boudiaf of Msila.
Mohammed Boudiaf of Msila, Algeria. Thank you. All right, so now let's go to the video. All of you see the video? Did you see the video?
Yes, it is clear.
All right, so Bismillah.
Hello, everybody. I am Saeed Qadri from Algeria. I'd like to participate in your conference with this presentation, which is entitled An Efficient System to Predict Customers' Satisfaction on Touristic Service using Machine Learning and Deep Learning approaches. This work has been realized by myself and Sarah Dahrizi and Safia Shapira, and presented by me. I will present according to the following plane. I will begin with introduction, then I explain what is sentiment analysis, and I talk about approaches of sentiment analysis. I present some related works. I present also the sentiment analysis process. I will present the proposed DNN model, and I illustrate experimental works. Then I present the obtained results, and I will establish a comparison between machine learning and deep learning approaches, and I will finish the conclusion and perspectives. People share their opinions, sentiments, views about a product or a particular topic by comments. Many companies exploit these comments in many interesting applications, such as improving the quality of their services, increase the number of customers, so on. So the main profits of any project comes from its effects on the sentiment of people, which can be positive or negative. So what is sentiment analysis? First, sentiments are feelings, opinions, views, emotions, or likes and dislikes. Sentiment analysis is a natural language processing task, and it can be defined as the process of extracting automatically the relevant information that expresses the opinion of the user about a given topic. A simple form of such analysis will be to predict whether the opinion expressed in a text is positive or negative. We talk about polarity. Sentiment analysis is useful in wide range of applications. We can cite business activities, government services, new medicine, and recommender systems and other applications. For example, when Ahmed says it is a great hotel, this is a positive sentiment. But if Omar says, I didn't like this movie, we talk here about a negative sentiment. So we have a polarity. We have a polarity which can take two values, positive or negative. For the approaches of sentiment analysis, we can distinguish 4 approaches. The first one is the NLP approach, or the lexicon-based approach. It uses semantics to understand the language, and it is based on some linguistic techniques such as dictionary-based technique and corpus-based technique. And the second approach is the machine learning approach. This approach doesn't require to understand the meaning, and it is based on machine learning algorithms such as naive Bayes, Sbm, neural networks, AdaBoost, and others. Third approach is the deep learning. Is a modern approach. It knows large success in many fields such as computer vision and image processing. This approach gives better results in terms of accuracy, and we have currently many models which are used, such as DNN, CNN, RNN, and LSTM. And we have fourth, the hybrid approach, which combines many other approaches. For the related work, we can found many works such as Gao and all, who developed a sentiment analysis system using AdaBoost algorithms and CNN model on movie reviews data set. And we can see also a Celeb et al. Who realized an opinion mining in Arabic using RNN model on Twitter. We can also find Pretty and all who realized the sentiment analysis for recommender systems in the cloud and used RNN and naive Bayes classifiers on Amazon datasets. We have also Zhang et al. Who presented the type survey of deep learning for SA, and they used CNN, DNN, RNN, and LSTM models on social network sites. We have also Wang et al. Who proposed a hybrid method for SA of reviews and used IMBD data set, and we can cite also Sheriff et al., who discussed the use of SI in the field of big data. And there are many other studies which apply deep learning for SA in different domains, such as finance, recommender system, cloud service, and others. For the sentiment analysis process, we must have a data set which is divided into two parts: the train set part, which represents 80%, and the testing set, which represents 20% of the global data set. Then we must select the relevant variables to use, and we proceed to a pre-processing task. Then we start the training stage to build a machine learning model and deep learning model. When we establish the machine learning and deep learning model, we must proceed to testing stage to evaluate the performance of these models. We generally use the K-fold cross-validation technique to have the accuracy of the model, or to evaluate the performance of our model, either the machine learning model or the deep learning model. For the proposed DNN model, we have proposed a deep neural network composed of many layers. We have the first layer is the input layer, and we have used 4 hidden layers. For each layer, we have dozens of neurons, and we also use an output layer composed of 2 neurons, because we have 2 places, the positive place and the negative place, or to express the polarity of sentiment analysis. For the experimental work, we have used the tribe advisor data set. This data set is composed of 68,336 highly polar reviews, and it can be divided into 2 sub-data sets. The train set, which contains 38,932 movie reviews, and the test set, which contains 29.404 movie reviews. For programming, we have used the Python language and other libraries such as TensorFlow API and Keras API, and their libraries of machine learning and deep learning. And we have worked in an Anaconda environment. For the obtained results, we have applied in the first stage machine learning approach. We have applied many algorithms of machine learning. We have used in our experimental work the algorithm called LDA, KNN, CART, and SSVM. And we have using 2 coding models, the binary coding model and the TF-IDF coding model. And we have obtained results which can be considered as low. The maximal value was 69.71, which is relatively low if we compare it with the DNN results. For the second model, the DNN model, we have used the training set and the testing set with the binary coding and the TF-IDF coding, and we have obtained best results in accuracy. For example, for the training set and for the binary coding, we have achieved an accuracy of 98.57%, and for the testing set, we have achieved an accuracy of 99.85%. But for the TF-IDF, we can see a small improvement in accuracy for the training set and the testing set. For example, for the training set, we have obtained 98.71% and 99.94 for the testing set, which is a good results, because we can represent its obtained results by curves. Here we can see the curves representing the evolution of the loss function, which begins very high and finish very low. This is correct for the binary coding and TF-IDF coding, and we can see here, we can observe that there is no difference between the two coding models for the loss function. The same here, we can see the evolution of the accuracy of our model for the binary coding model and the TF-IDF coding model, and we can see here that accuracy begins very low and ends very high for the two models. But we can see some improvement for the TF-IDF coding model. The accuracy is very high if we compare it with the binary coding model. But it is a good and best results compared with the machine learning algorithms. We can also establish a comparison between machine learning and deep learning approach in terms of accuracy for the binary coding model and the IDF coding model. And we can see here that the obtained accuracy for our DNN model is the best. For example, here we have obtained 99.85 for the binary coding and 99.90 for the TF-IDF coding, but the accuracy obtained when applying machine learning algorithms is relatively low. The maximum value was 69.71. So as conclusion, I can say nowadays sentiment analysis is a hot topic in deep learning. In this work, we presented the different approaches used in the sentiment analysis field, especially the machine learning and the deep learning approach. We illustrated the well-known studies and researches down in this interesting area. We have used in the experiment part two coding models, TF and TF-IDF, and a tribe advisor data set. We also presented the detailed architecture of the proposed DNN by giving the different layers and the number of neurons in each layer. We conducted many experiments to evaluate the different machine learning algorithms as well as the proposed DNN model on data sets. The performance experiments show that our model gives high accuracy for sentiment analysis detection, which is not the case when applying machine learning. As perspectives, we can propose the following. Using other coding models such as embedding words and engrams technique. We can also exploit other deep learning models, notably NM, RNN, LSTM, and other hybrid models combined with TF-IDF, word embedding, and engrams techniques to improve the obtained accuracy. We also plan to use other data sets and establish wide comparison between them. I thank you for your attention, and I am happy to participate in your conference, and I wish you a successful conference. Thank you.
Thank you very much. Thank you.
Thank you very much. Go to the next video.
So can I give my PPT online? Is it okay?
Yes, is it okay? Okay. Just let's start with code 193 and ensemble classification approach using improvised attribute selection. Muhammad Qasim, Maymoon, Shingwan, Kui, Yulu, Asma, Maymoon, Abdul Rahman, Maymoon. Mehran University of Engineering and Technology, China. Almost welcome.
Hello everyone, and assalamu alaikum. This is Dr. Muhammad Qasim from the University of Sufism and Modern Fancy British in Pakistan, and I also represent the Beijing Normal University postdoc fellow in China. Today's my topic is about the ensemble classification approach using improvised attribute selection. And this conference paper is presented by Dr. Mehmet Asmama, Professor Dr. Session12, Professor Dr. Yulu, Professor Dr. Asmama, and Professor Dr. Mehmet. As this conference paper is represented in the International Air Conference of Information Technology as 2021. So let's move to the next slide. And next slide is about the research overview and objectives. First of all, I want to give a glimpse about the overview of this research. So in this paper, we improved the prediction of student performances and evaluated the features that contain 6 categories of attributes in several domains, that is demographic, personal, academic, parental support, psychometric, and mathematics. The prediction usually in data mining contains with different classification of words using several methods of accuracy and comprehensibility of early prediction. That's why in this work we focuses on several methods. So the results performances show that the appropriateness of performing prediction and ability both the filter and paper-based methods for feature selection. So in this paper, we use a feature selection method technique that is called filter and paper-based methods. So in our finding, we also show that the student performance with the most impactful features using ensemble methods and the feasibility of creating the prediction model with a reasonable accuracy. So in this paper, the objectives, main 3 objectives in this research work are the exploration of the best impactful features plays a vital role in predicting student performance. Analysis of a paper selection based on the improvised filter and paper-based method, and the novel ensemble classification approach extract invisible and intrinsic connection among the feature of the students and their performances. So move to the next slide is about the introduction. In the educational data mining, that allows to find patterns and improving the quality of education process. In this process, the assessment and student performance is a great important for themselves as well as benefiting the education and institutions. So in doing so, in this session, we improved the prediction of the student performance and evaluated the features containing 6 attributes. On the right side, you can see the diagram containing 6 categories of the attributes or features that may be related to personal, demographic, academic, parental support, psychometric, learning, which are considered in this work. So the prediction of different classification approaches based upon these 6 categories of attributes gives us the accuracy that affects the accuracy and comprehensibility of the early prediction. So next we will discuss about the related work done in this research work, and we observe that how they are overcoming the likenesses and weaknesses in the past few papers. So I just took a little very short table on the right side. You can see that I just cited 4 research papers in my conference paper. So prediction of the student performance emphasizes in these 4 papers that is rely upon the academic features, as you can see in the table in the middle column. These 4 works are related with the academic features or demographic features and personal features. So no work has been utilizing the psychometric features and learning now, which we have considered in this work. So this is what we have overcome from the previous works. So this is the data description. We just use a vector software to analyze the data, how the loop likes, and you can see the different attributes here. And these attributes and the last attribute substitution is a target level, and we have just have a formula to calculate the overall final score of the attribute. This final grade comprises of 3 partial components, that is psychometric score, learning log score, and final score. So each score is graded differently. For example, a psychometric score is 25%, learning log is 35%, and final score is 40%. Actually, this data is about 3 years from 2016 to 2018, and it is where the students were logging into the systems. It is called the Smart Learning Portal system. It is produced by Advanced Innovation Center for Future Education based in London University, where I am currently working. Next, we have methodology. Our ensemble clustering approach follows the classification model evaluated based on the cross-validation and split-validation. So in processing, we just done the data integration, discretization, and cleaning. So make sure that no null values or repetition of the data is allowed. So attribute selection is implemented by both the feature and wrapper-based method. And in this model, we use 10-fold cross-validation. And this is our complete model. You can see that 2 phases, pre-processing phase and model evaluation. Next, we have experiments, and we have divided our experiment into 4 different categories. First, we have evaluate our features and how they are important. So to evaluate features, we use filter and wrapper-based techniques. And in this work, we actually addressing 3 research questions. In the top right corner, you can see that these 3 questions are attribute analysis using selection method. What are the attributes that we should use? Analysis of state-of-the-art prediction models and prediction model performance ensemble. So one by one, we'll address these questions. Let's come back to the results of this feature selection. So we performed the filter-based method using different attributes, and we also perform the cross-validation of all attributes, and we are getting the results. And this is also indicated that the highest score with the 0.861, 0.74 accuracy, 0.81 accuracy, and respectively. So this score is not associated with individual model as a whole, rather it represents the basis score conceived by the different models. So this was the experiments based upon cross-validation constituting all attributes. In the next slides, I would like to show that the cross-validation on selected attributes that actually done on the filter-based method. So results suggest that random forest and random based upon the information gain and random forest based upon the Gini index achieved higher scores in terms of accuracy 0.90, top of its value 0.74, and F1 score with 0.81 using 10 cross-validation. So you can see that all the models, JReport, SMO, NIPACE, deep learning, linear regression, K-star, and decision tree having 3 variants, random forest having 3 variants. These result performance of classification model using 10K-fold cross-validation gives very superior results by using random forest and decision tree. Now we would like to show the effect of ensemble classification. As the result indicate that classification model with the random forest and decision tree achieved higher score, and the performance model classification models with the decision tree, random forest, and K-star would get superior scores than the baseline performance. Remember that baseline performances are the solidly classification model, and the ensemble model are adding with the bending and boosting techniques. The conclusion of this present paper is we present the ensemble classification approach, a novel classification approach that performs attribute selection via an improvised filter wrapper-based method. We testify our experiments on a large data set which is composed of new features in different domains. The proposed framework validates the results via both 10 cross-validation and split validation. So ECA can identify student performance, whether they pass or fail in their final exams, and it also resembles an indiscernible and intrinsic connection among the features of the student in their performances. So our findings indicate that ensemble methods are devised with a classification model that can actually help predict student performance. So the results also indicate that features including family, psychometric, learning logs, are more impactful and can be given much attention in any education setting, improving your student performance. So thank you very much. If you have any questions, please let me know. Thank you.
Done. Thank you very much.
Thank you very much.
So now let's go to the number 201. Driver process detection by employing CNN and DLib. Nawaz, Ali, Imran, Hassan, Tinsel or Rida Al-Hajj, TOBB University, Turkey. Any person from this author attend, because we didn't receive any video from them. So any person.
Yes, I am here. If you want, I can present online. I have the video. If you want, I can play the video. As I see, you preferred the recording, so I can play the recording.
All right. So now you have the permission to do the share for your screen and play the video. Please.
Who is speaking?
It's me, Nawazish.
Okay. Okay.
Okay, let's go.
Okay.
Stop my share and you can share now. Yes, Nawazish.
I'm sharing. Wait a minute, please.
Okay.
Yes, now can you see the video?
Yes, we can see clearly. Please.
Okay, thank you.
Play the sound. There is no sound, no sound.
I played the sound.
I'm hearing you.
You cannot hear me?
No, I'm hearing you.
Okay, okay, thank you.
Now, I'm not hearing you now.
Sir, I'm playing the video with the voice, but I don't know why can you. Anyone else cannot hear?
Yes.
From the video, I cannot hear.
Just we see the screen, but without sound. Your sound is okay. Your sound is okay, but the video sound not.
The video sound is not.
But I'm playing the video with the sound. Okay, I can present online if you want.
It's okay.
I think
Just control the time. You have.
you cannot hear.
No, still not.
We are hearing you, but the video is not.
Okay, okay, I'm presenting online. Can you see my slides? Okay, I'm Nawazish Ali, and today I'm going to present our work, which is driver drowsiness detection by employing CNN and DLib. The author of this paper is Nawazish Ali, Imran Hassan, Tensel Ozair, and Reda Al-Haj. First of all, let's see the synopsis of our presentation. Its introduction, data set, methodology, results, and conclusion. First of all, we will see the introduction. As we know, advancement in technology improve the economy, which increase the purchase power and lifestyle of the paper. Nowadays, everyone wants their own vehicles and have a personal vehicle. So due to advancement in transportation system, everyone likes to traveling, and the roads of the world are now shared by all type of traffics like cars, trucks, vans, and taxis. This results the increase in number of vehicles on the road. According to European Automobile Manufacturer Association (ECMA) in 2018, said that the total number of vehicles on the road has increased up to more than 380 million, which include both commercial and private vehicles. The increase in the number of vehicles on the road increase the number of chances of the road accidents. Driver fatigue and distraction is the second most cause after the overspeeding, and its factor is 20% of the road casualties. After the introduction, let's see the data set we use for this work. We use two different type of data set for this work. The first one is the images data set, and the second one is videos data set. The images data set names is driver drowsiness data set, which is publicly available on Kaggle website. It contains 2,900 images of four different categories: yawning, not yawning, eyes closed, and open eyes. The second data set was the videos data set, and its name is driver drowsiness detection data set. We extract the 3 frames per second from the video and extract total 200 of image. And this data set is publicly available on National Testing Hawaii University portal. And after this, we combine the. You were saying something to me? Hello?
Continue, please continue.
Okay, so at the last we combine these data sets, and after the combining these two data sets, we split the 70% and 30% data set, 70% data set for training and validation, and 30% data set for testing. If we see the methodology, we implemented 2 different techniques for this methodology. In the first technique, we use the very famous DLib library, and which uses Harcase classifier for the detection of face and detection of facial points. From these facial points, we detect the facial point of eyes and mouth. And from these facial points, we calculate the eye aspect ratio and mouth aspect ratio from these points. Here in the image left-hand side, you can see the points of the eyes, which we detected from the image. And here is the formula to calculate eye aspect ratio. On the right-hand side are the points for the mouth, and below image is shown the formula for calculating the mouth aspect ratio. This is the technique 1, and after this, the second technique we use is the CNN architecture ResNet 18. We train this architecture. First of all, we take this trained architecture and unfreeze all the layers, and then train the complete model. And we applied the learning rate of 0.01 with learning scheduler. And we also, and here below, you can see the figure of this ResNet 18 with it has 17 convolutional layers and 1 fully connected layer with skip connections. And we try some other ResNet 18 ResNet architecture like ResNet 52, ResNet 101, and ResNet 152. And ResNet 18 gives us the very good accuracy, which is almost 98%. Here on the right hand side, you can see the loss graph and the training and validation accuracy of our model. After this, we combine these 2 methodologies, and here is the complete diagram of these 2 methodologies. First of all, when we start our application, it captured the image of user, and then split the image, send the images into 2 different libraries. The first one is DLib, and the second one we call it NLib, which is our trained model. The DLib calculate the eye aspect ratio and mouth aspect ratio, and we set some threshold on this. For the ear we set is 25%, and for the mouth aspect ratio we set 25%. And if the value is less than 20% and 25%, we say the driver is drowsy. And on the NLib calculate the eye clear ratio and the yawning of the person, and if person is, the eyes of the person is closed and his yawning is says that the driver is drowsy, and on the basis of these two output we finally say that the driver is drowsy or not. If we say the results, we can see that by combining two different data set and combining two different techniques, we achieve overall accuracy of 95%. Here on the left hand side in the images you can see the driver drowsy images which our model detected successfully, and here on the right hand side you can see not drowsy images, and our model detected very successfully. And after this, if we talk about conclusion and future work, we can say that combining two different data sets and combining two different methodologies give us very good results. And for the future work, we want to improve this work by considering the facial expression of the driver. Currently, we are detecting the eye aspect ratio and mouth aspect ratio. For the future work, we want to detect the facial expression of the driver. Thank you very much for listening. And if you guys have any question, you can ask. Thank you.
Thank you. Presentation, and still we have the final or last presentation to show for today will be.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته.
كان في سؤال بس للدارس للباحث الأولاني القديم، حضرتك ممكن نسأله ولا ما فيش وقت؟
باقي فقط برزنتيشن واحد ونفتح مجال للأسئلة.
يعني الأسئلة نخليها لآخر الجلسة؟
بالضبط كده يعني.
طيب حاضر.
شكرا جزيلا. 213 scheduling UET UCT DAGs of depth 2 on 2 processors. Rosian Quadora Ghassan Samra Naam الزرقاء University Jordan. Any one of two authors available with us today? All right, let's go to the video. 213. Did you see the video, the presentation?
Yes, we can.
Okay, so let's move to the video.
Assalamu alaikum. I am Rosen Padura from Jordan, Zalka University, Computer Science Department. We present a linear time algorithm for scheduling in tasks on two processors where all the tasks form a DAG of depth 2. The execution time of every task equal to 1, and the communication delay between any two particular tasks is also equal to 1. The presentation consists of 4 sections. First, I will present an introduction about the general form of the problem, then a literature review, then I will present the grand line of our algorithm. Finally, I conclude by future research that can be follow this work. Scheduling problems have been studied extensively for at least the first 15 years. Generally speaking, scheduling is concerned with allocation of scarce resources to activities with the objective of optimizing one or more performance measures. As a simple example, resources may be courses and activity may be classrooms or teachers. The objective is to allocate the courses on classroom or on teachers in optimal way. The general scheduling model consists of a set of n tasks
to be executed on a set of M processors. Each task J is characterized by its processing time. Several criteria can be found in literature to schedule the task on processor. One of these criteria is to specify which task should be executed by which processor, subject to precision constraint, and may be without communication delay. The objective is in this criteria is to schedule all tasks on the processor such that the finishing time of the last task is minimum. This problem can be represented by a task J equal to B, E called a task graph. B is the set of tasks and E is the set of precedence constraints. A weight Pi is associated with every task I represents the execution time of the task I. And a weight Cij is associated with every Hij represents the communication time between the task I and J. If Ij belongs to E and the task I start with execution time at time T on a processor B, then either J starts execution on B at time greater than or equal to T plus Pi, or start its execution on some other processor at time T plus Pi at time greater than or equal to T plus Pi plus Cij. This problem is denoted as Bm precedence Pi Cij Cmax, where Bm is the number of processors. Precedence represents the precedence constant. Pi represents the execution time of every task J. Cij is the communication time between task I and task J. And the objective is to find Cmax. We find in the literature that the complexity of the problem Bk precedence Pi equal to 1, Cij equal to 0, Cmax is open. That is, this problem till now, there is the complexity of this problem is unknown, where K is fixed. But if K equal to 2, the problem B2 precedence Pi equal to 1, Cij equal to 0, Cmax is solvable in polynomial time. For any fixed K, when the precedence graph is restricted to certain special form, the problem Bk precedence Pi equal to 1, Cij equal to 0, and the objective is to find Cmax, turn out to be solvable in polynomial time. This is possible for unit tree, auto tree, opposing forest, and interval order. Also, in the literature, we find that the problem B3 precedence Bi equal to 1, Cij equal to 0, Cmax remain an open question. And the problem B2 precedence equal to binary tree Bi equal to 1, Cij equal to C, where C is a large integer, is in B hard. But this problem is polynomial if the precedence of the task graph is a complete binary tree. A challenging problem is the two processors scheduling with UET UCT. That is the problem B2 precedence Pi equal to 1, Cij equal to 1, Cmax, for which the complexity is unknown. In the literature also we find that this problem is polynomial for tree and interval order and a subclass of series parallel graph. We propose for the problem B2 precedence Pi equal to 1, Cij equal to 1, Cmax, a linear time algorithm to compute an optimal scheduling for the class of depth 2. That is the graph for which the vertices can be partitioned into 3 subsets A, B, C, and every edge connect between A and B, or between B and C, and there is no edge between A and C. The structure of depth 2 set of vertices A, then the vertices of B, then the vertices of C. That is, there is always a feasible schedule that satisfies this property. From this remark, we conclude that any optimal scheduling must be satisfy the following inequality: Cmax greater than or equal to cell of A union B union C on 2, and smaller than or equal to cell of A union B union C on 2 plus 2. The general idea of our algorithm is the following. The algorithm start to find the last two vertices A1, A2 that must be scheduled before scheduling any task of P. Then find the first two vertices B1, B2 that must be scheduled directly after A1, A2, and the last two vertices of P, B3, B4 that must be scheduled before scheduling any task of C, and finally the first two tasks of C, C1, C2 that must be scheduled directly after C1 and C2. The essential mission of our algorithm is the decision whether the vertex B1 or B2 and B3 or B4 exists or not, and the decision whether the vertex C1 or C2 exists or not. For technical reasons, the algorithm produces an optimal scheduling in reverse. That is, it starts to schedule the vertices of C first, then the vertices of B, and finally the vertices of A. We call every pair A1, A2, B1, B2, B3, B4, and C1, C2 a hinge. The algorithm using mathematical tools find the hinge C1, C2, and if this hinge is scheduled, must be scheduled in series or in parallel. Also, it finds the hinge B1, B2, B3, B4, A1, A2, and characterize if these hinges are scheduling in parallel or in series. So the building of optimal scheduling for adapt J equal to A union B union C, where called A of depth 2 start by find the right hinge C1, C2 of C and the left hinge B1, B2 of B in the adjacent subgraph J, B union C. Then find the right hinge B3, B4 of B and the left hinge A1, A2 of A in the adjacent subgraph J, B union A, or for the subgraph J, B minus B1, B2 union A. If B greater 3 in the last case. Finally, schedule the vertices A, B, C alternately on B1 and B2 in the order C minus C1, C2, C1, C2, B1, B2, B minus B1, B2, B3, B4, A1, A2, A minus A1, A2. The complexity of this algorithm is O of M plus N, where M is the number of edges and N is the number of vertices. For example, when we apply this algorithm on this graph, it finds that the right hinge of C is C4, C3, and the left hinge of B is B4 and I is imaginary vertex, that is not exist. And the left hinge, the right hinge of B is B2, B1, and the right hinge of A is S3, A2, and the rest of this for this graph is equal to C. following. We believe that our algorithm can be generalized for any data of arbitrarily edges and without jumping edges. That is, edges between two non-consecutive labels. If this is the question that maybe the following. Is it possible to use this generalization for solving this problem in general case using this generalization of this algorithm? We hope that this is possible. Thank you for your attention.
Done. Thank you very much for all. And now we have few time for opening the discussions and questions depends on the previous papers. تفضلوا بالمناقشة إذا أحد يريد يناقش. هل الصوت واضح؟ هل تسمعوني جيدا؟
نعم شكرا نسمعك دكتور نسمعك.
نعم please if anyone have a question please you can do the questions and the author of the paper will give you the answer.
Of course, for presenter who are present here.
Yes, sure. Do you have any question, please? كان في أحد الدكاترة يريد يطرح سؤال. دكتور قاسم. دكتور قاسم، أتوقع الدكتور قاسم عنده مشكلة في الاتصال، دائما يفصل ويرجع يفصل ويرجع. فإذا كان لا توجد أي أسئلة أو استفسارات نكون كذا قد أكملنا هذا السيشن. ونشكركم جزيل الشكر لمشاركتكم معنا في المؤتمر العربي الدولي لتكنولوجيا المعلومات ACIT 2021 بجامعة سلطان قابوس بسلطنة عمان. شاكرين لكم هذا العطاء هذه المعلومات، ونلقاكم إن شاء الله في مؤتمرات قادمة، وعسى أن نستضيفكم أيضا في سلطنة عمان وتكونوا حاضرين هنا لايف بإذن الله تعالى.
شكرا لكم على حسن الضيافة وجودة التنظيم. أقل من واجبنا هذا يا دكتور، ونحن أيضا نشكركم جزيل الشكر على وقتكم الثمين وعلى إنتاجاتكم الجميلة والمعرفية التي لا شك ستسهم كثيرا في هذا الحقل. الآن بإمكانكم الخروج، الذي يريد أن يخرج بإمكان الخروج، والذي يريد أن يسأل يتفضل.
شكرا دكتور شكرا.
جزاكم الله خير. Professor Farida, we cannot hear you clearly. Your sound is interrupted. يتقطع الصوت يتقطع. لا نسمع أي شيء. شكرا لكم، والآن سنغلق الجلسة. Thank you very much. Now we are closing the webinar.
Thank you.
Thank you. You are most welcome.